in testing, we have this pathology. And I think there's a feedback loop at work here. We got a whole bunch of people who are obsessed with writing test cases, which is a terrible way to model testing. And then we've got a whole group of people who are trying to evaluate the progress of a testing effort by looking at the number of test cases we wrote at the beginning of the project, precisely at the time we knew least about it, ignoring everything that we've learned so far in the project, and they're asking, we had 280 test cases. And it's a well, I'll make the numbers easier. It's a 7-week project, so we should be doing 40 test cases a week, right? If we're gonna get them all done? What a stupid way to do it, because you know what? In week 1, we're gonna learn something. One of the things we're gonna learn is of those 280 test cases, 130 of them were stupid. Didn't apply to the product that we're actually developing. Then what's gonna happen? The week after that, we're going to decide, you know what, that feature that we wanted, we didn't have a clue about what we actually needed. And some people say, scope creep, requirements creep. It's not scope creep, it's not requirements creep, it's requirements discovery. Scope realization, scope recognition. Oh no, if we want this, we didn't realize that we're going to need this and this and this and this too. And so now another 100 test cases are irrelevant. So let's not do that. Let's not do that. I mean, do pilots use piloting cases? Complex cognitive activity piloting, do they use that? What about parents? Do parents use parenting cases? How about scientists, researchers? Do researchers use research cases? And for the nail in the coffin, when a manager is asking us for test cases, do managers use management cases? So why do testers use test cases? Well, I think, as I said, there's a feedback loop at work here. Managers like test cases because they make testing legible, readable, understandable, quantifiable. Oh, okay, 280 test cases to do. We've done 40. We're 1/7 of the way through the project. We're on track. This is crazy, though, because the purpose of testing is not to confirm that the product works. The purpose of testing is to investigate the product. That's what we're trying to do. We're trying to discover things about the product that we didn't know, that we didn't anticipate, that we didn't realize. We're trying to discover things that people need to know in order to manage risk. Well, testers keep talking about test cases because managers keep asking about them. And they do that because testers keep talking about them. Because managers keep asking about them, because testers keep talking about them, because managers keep asking about them, because testers keep talking, because managers keep asking about them, because testers keep talking about them. Because managers keep asking about them. But smart people can do way better than that. Way, way, way better than that. First of all, how do we do it? First thing is, let us distinguish, please, between testing and checking. I'm actually, if I'm remembered for anything, and Lord knows I barely deserve to be, but it'd be kind of cool if I am remembered for basically restoring something that Alan Turing knew about and specified, that there are things you can do with an algorithm to check its output. But that's not the same as testing. That's not the same as testing. Checking is a good thing. A lot of people have been very offended by this distinction because they say, well, wait a minute, what you're saying is that test automation is no good, not worth it. I write test automation. Well, we'll get to that point, but basically we don't believe there's such a thing as test automation because testing cannot be automated. I'll return to that point. Operating a product to check specific facts about it, what we do is we get the machine to punch its own keys, and we ask it to make certain observations of its own behavior, and then to apply decision rules to do, based on those things that we did in specific ways, to collect specific observations, apply decision rules to the observation, and then to alert us to any failed checks. Anything that fails, we want the machine to let us know about that. So let's review 3 parts to a check: an observation linked to a decision rule. such that both the observation and the decision rule can be applied algorithmically by a program, which means that a check can be performed by, number one, a machine that cannot think but has certain virtues. It's very fast, very precise, it's tireless, it's deterministic and unimaginative. We want it to be unimaginative because we want it to check specific conditions in specific ways. A check can also be performed by a sufficiently disengaged human being. A human being who's been instructed not to think but to follow the script and make this specific observation of specific activities that result in specific outcomes. But the thing is, people do that slowly and variably, and the variable part is really damaging to the idea of doing a check because people will compensate. People will do things that the machine will just hang up on. The machine will be unable to complete the check. Humans will find inventive ways around problems that they see when they're being asked to perform a check. And the trouble is, a lot of the time they won't report it. Right? The problem that they encountered, they'll suppress it. Testers don't want anybody to know that they're not doing the thing right, and if they encounter a problem during the check, that would be an indication that they're not following the program. So a lot of the time, there's a great temptation to suppress a surprising observation or a surprising outcome and to behave as the machine would behave. That's what happens when we give testers scripts that over-focus them. And testing should not be too focused unless it is specifically your intention to miss lots of bugs. Checking is an act of confirmation, trying to make sure that what we think and what we hope is true remains true. But even when we've done fabulous checking, a product can still have terrible problems. I think it's okay. It's important, in fact, to do checking. It's a great tool. It's a great tactic of testing. Checking is. But testing is more than that. Testing it includes checking as a tactic, as something that we do as part of testing. But first of all, it doesn't have to. It's probably a good idea, but it doesn't have to include checking. Because for example, when I encounter iTunes, I don't have an agenda in my head. I'm not operating iTunes to check specific facts about it. I'm operating iTunes to see if I can get value out of it. If it does for me what I would like it to do, not what I expect it to do. I expect it to screw up. But what I'd like it to do. So that's another thing, testers, please, for heaven's sakes, let's drop this idea of expected result, okay? Let's drop the expected result idea. It's tired, and a lot of the time when we report using actual result and expected result, it gets kind of offensive. Actual result, did this and that and this, and the program crashed. Expected result, the program should not crash. I was saying today in the class, if I were a programmer and I got that kind of report, I would set up a trebuchet and I'd put the tester in it and I'd launch them over to the other side. It's so insulting when we construct stuff that way. Why don't we say, I observed this problem. Here's an example that would allow you to see the problem. And the example doesn't have to include step-by-step instructions. If anybody who's working on the project knows how to get there, it might need step-by-step instructions, but it might need, as an alternative, it might need just the data, right? Go to this place. You don't need step-by-step. Here's another thing that happens, by the way, when testers report a problem. Their step-by-step instructions so helpful to the programmer start with 1, start the program. You left out step 0, buy a computer, right? Shut up. Get to the point. Give me what I need to reproduce the problem. Give me an example. A screenshot might do. Just a screenshot with a brief description of the problem and the oracle, why you believe it to be a problem. Now, in rapid software testing, the style of software testing that James Bach and I teach, you want to know why I'm seeing a problem? I'll tell you, because I'm seeing something that's consistent with a pattern of problems that are familiar to me. I see something that I can't explain. I don't understand it, so I suspect that there's a problem here. I see something that's inconsistent with the way I know the world works. Therefore, I suspect that there's a problem here. I see something that is inconsistent with the product's history. Product used to work like this, now works like that. I see something that's inconsistent with an image that our organization wants to protect. I see something that's inconsistent with claims that important people have made about the product. I see something inconsistent with comparable products, our products like this, or competitive products, or products within our product suite, or an algorithm that can accomplish the same thing that our program is supposed to do, a tool that provides me with a comparable result. I see things that are inconsistent with user desires, what a reasonable user might desire, not expect. Not expect. I expected Windows Vista to suck. It sucked, completely consistent with my expectations, still not what I wanted. If its product's inconsistent with itself, if it's inconsistent with an implicit or explicit purpose for it, if the product is inconsistent with relevant standards, laws, statutes, regulations, conventions, then I suspect that there's a problem here. When I have that list of oracles in my head, that list of patterns of inconsistency, then I don't need a requirements document to find lots of bugs. Moreover, I don't trust the requirements document to be accurate anyway. It's something that somebody wrote down a while ago that was attempting to capture some subset of what somebody thought somebody else wanted back then. And there are so many ideas floating around that they're inconsistent with each other, they contradict each other in some places. The requirements document is not terribly reliable. Brian Merrick had a nice line about requirements documents. They should be treated as useful fictions. Potentially useful fictions. With that set of ideas in my head, I as a tester can walk in unarmed with a requirements document. I can get information from all over the place, and I can engage in testing, which is evaluating a product by learning about it. Evaluating a product by learning about it through exploration and experimentation, which includes a whole host of activities, none of which can be automated. Modeling the product, modeling the test space, modeling the user, obtaining resources, trying to figure out what can help me test and who can help me test, collaborating with people, generating ideas, elaborating on ideas, refining ideas, overproducing ideas, abandoning ideas, recovering ideas that I've abandoned before, creating tools, developing checks, evaluating the outcome of checks, encoding checks, considering ideas about risk, considering alternative interpretations for what I'm seeing, applying critical thinking skills, applying general systems thinking skills. None of these things can be automated. But to use and develop testing tools, including automated checks successfully, this is where I want to test, what they call test automation people, or automated testers. What a silly way to say it. You're not an automated programmer. You use a compiler, you're not an automated programmer. You're a programmer. I want desperately to reassure people who are engaged in developing and using tools to test software and to program automated checks that I am not hostile to them. I'm not being dismissive of what they do, because they need to combine skills, sets of skills, that they'll be lost without, that we would be lost without. We need both programming skill and testing skill to be really good check developers. And somewhere along the line, that message got lost. I think it got lost. I think it's partly my fault. Partly my fault. And then it's partly the ultra-blind notion about versus as opposition. Here's where my fault. I called it testing versus checking. What I meant was testing as distinct from checking. Like eating as distinct from biting, right? I didn't have much lunch today, okay? It's that I'm trying to do the low carb thing, you know, well, so that I can drink more of that. I'm trying to stay low carb, so I didn't eat very much lunch today, and I'm really hungry. So as soon as we're done here, I'm going to go down somewhere, Queen Albert Street someplace, and I really need to bite something. Because proper biting is an important part of a healthy lifestyle, right? We should bite thoughtfully, okay? And sometimes, actually, you know, when we think about it socially, it can be very nice to bite together. But we don't make that distinction, we don't lose that distinction between biting versus eating. We don't even lose that distinction between compiling versus programming. No programmer who uses a compiler says, well, I'm an automated programmer. Nobody calls it automated programming when they use a compiler. That's because compiling is the part of programming, a part of programming, that can be entirely done by a machine, by algorithms. So, dear automated tester, call yourself a tester. If you want to designate yourself as a tester with a particular specialty, how about a testing toolsmith? How about somebody who uses tools to check the software? How about designating yourself as a tester specializing in tool development? If you want to make yourself respected, then why not focus on the thing that only humans can do, the testing part, and don't declare yourself as automated. Yeah, I use all kinds of tools when I cook. I'm not an automated cook. I'm cranky about this because there has been, for a long time, a movement, you've heard this before, why can't we just automate all the testing? Well, if we could do that, we will have achieved true artificial intelligence because we would have something that could read people's intentions. But if that were true, we could automate all the programming as well. Why don't we just automate all the programming? Why don't we just automate all the development? Why don't we automate all the software development? I'll tell you why we can't automate all the testing, because machines cannot do that, or 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 that. Machines can extend the superpowers that smart people with smart brains have to do all of those things. But let us not make the mistake of saying that the machine can do that. Deep Blue beat Garry Kasparov? Deep Blue, the machine, beat Garry Kasparov? Bullshit. A team of chess experts and computer programmers and hardware designers armed with a machine beat Garry Kasparov. You need a small army of people to beat Garry Kasparov, and they need a big machine to do it with. That puts Garry Kasparov in the proper perspective. That puts humanity in the proper perspective. Enough people working together with a big machine can do pretty amazing things. They can defeat a single unarmed guy. A very American way of thinking about that, I'd say. But testing is even more than that stuff. Testing is also another thing that machines can't do, creating the conditions necessary to do all that stuff. so that our clients can make informed decisions about risk. And machines can't read our clients' minds, and machines can't evaluate risk, except to the degree that people use the machines as tools in assisting them to evaluate risk. And actually, testing is even more than that. Testing is developing the inclination, the intention, the desire, the motivation, the reputation, the skills to do all that other stuff. Oh, and by the way, if we do a really good job, and if our clients make good use of the information that we provide to them, we can contribute to making the product better too, in that sense. That is to say, we can inform them in the same way, not in the same way as we make the laws. We don't do that as testers. We don't make the product. We don't build the product. We don't break the product either. The product was broken when we got it. The product is what it is. As James so wonderfully puts it, we break illusions. We break dreams. We're not in the confidence building business. We are not confidence men. We are in the unwarranted confidence demolition business. It's our job to take, not confidence generally, but confidence that is unwarranted. It's our job to pick holes, to chip away at that weak leg in confidence and help it to collapse appropriately so that our clients can make informed decisions about the product. And in doing that, that's our special sauce. That's what we bring to product development. Now, we don't use the word defect in rapid software testing anyway. We don't use the word defect. The reason we don't use the word defect is I don't know whether something's a defect or not. If a product is perfectly coded and somebody just doesn't like it, is that a defect? If you see something you don't like and the person next to you sees something that they like just fine, is that a defect? Another James thing. If you go to your spouse and you say, you know, there's something that you're doing that bugs me, they probably react badly enough. But if you say, you know, you have a defect, there's a defect in your communication if you do that, and you're going to bug them. So what we say is bugs. A bug is something that threatens the value of the product to some person who matters. That's the formal definition. Less formally, a bug is something that bugs somebody who matters. And what that does is it puts the word bug, the idea of bug, into the subjective realm, which represents reality. Because what is a bug to you? Not a bug to me. What is a feature to you? Bugs me. That's okay. We're going to have to come to a decision at some point. As product managers, we're going to have to decide whose values matter. It's a tester's job to identify whose values might matter and how they might be threatened. In order to do that successfully, one of the things that we have to get around as testers is issues. In rapid testing lingo, the rapid testing namespace, an issue is anything that threatens the value of our testing, or of the project, or of the business, but most importantly of the testing. Anything that threatens the value of the testing work, we call an issue. And it may be the case that issues, any given issue, might be more important than any bug that we've found so far. That's because issues give bugs time and opportunity to hide. The bugs that we found, by definition, are the easiest bugs to find. If there were easier bugs to find, we would have found them earlier. Issues are the things that slow us down, make testing harder, and they include, among many other things, two things that I think testers, unfortunately, are not very good at reporting. The amount of time that we take for setup, that is, preparing the test, that cannot find a bug, right? In doing setup, we define setup pretty carefully as the time in which we are getting ready to test, but during which we could not find a bug. So setting up the environment, getting ready to install the product on that environment. We can't find a bug in our product as we're doing that. Now, mind you, if we're setting up our product, we might be testing our product at that point, right? Testing the installation process. That's set up for the product. We report this in terms of the highest priority stuff. First, testing is what we're looking for. We're looking for gold. The gold is test coverage. Learning something about the product. We're learning something about our product as we're setting it up. We're not doing that as we're setting up the environment. That's overhead. It interrupts testing. Here's a subtle one. The more bugs we find, the less time we have to test. What? But bug finding, that's testing, isn't it? Finding a bug and reporting it, investigating it, that's testing work. Yes, it is. But it doesn't add to coverage. When we're investigating, oh, look here. I've got tiles on the floor. I'm looking for a problem here. Spend 2 minutes on it. No problem. Look at the next one. 2 minutes on it. Oh, no problem. Look at the next one. Oh, there's a problem here. Now I have to investigate it. Now I have to see if there are other problems like it in this area. I have to report it. I have to write it up. I have to try again to see if the problem persists, whether it's intermittent or whether I have to do special things in order to reproduce it. And as I'm doing that, I don't progress to the next square. So, paradoxically, finding bugs prevents us from finding bugs, from finding more bugs. And that's really important because developers aren't going to get the time to do unit checking, to test their own work until we testers start getting good at noticing this. That finding bugs takes time away from finding more bugs. And the programmers aren't going to be allowed to do this until we start to realize, as a development group, just how much time that's taking away from further progress. One way, I love the way J.B. Rainsberger puts this. Programmers say, but it'll take us all this extra time. If we have to develop unit checks, if we have to test our code. No, it doesn't take any extra time. That's just time that you were getting away with not spending up until now. Coverage. Coverage is how much of the product we've tested based on some model. An oracle, that I already mentioned, is something that helps us to recognize a problem when it happens during testing, a means by which we recognize a problem. So, if we want to get what we want from testing, I think we have to get very good at telling the testing story, which is a story that has 3 interwoven plot lines in a playet or a braid. The first strand in the braid, we don't tell them in order, that we weave them around each other. The first strand is the one that probably matters most to our clients. It's a story about the product, what it is, what it does, how it works, how it might not work, how it fails, how it might fail in ways that matter to our clients. That's a story about bugs, and where we're uncertain about whether there are bugs there or not, learning about the product, realizing that there's a potential for bugs here, that's a story about risk. In order to back that story up, in order to give warrant to that story, another strand, a story about how we tested, what we did to get the first level story, how we configured and operated and observed and evaluated the product, how we recognize problems, why we believe that they're problems, what we've covered, and what we have not yet covered. Important testing that we have not yet done. Stuff that we believe risk lies underneath, so that our clients can say, what, you haven't done that yet? Let's get on it. What, you don't intend to test that at all? We need to test that. There's risk under there. And then we say, all right, in the 2 weeks that you say we have left, can we please get your help in identifying where our priorities should be? We want, just as badly as you do, we want you to ship a successful on-time project. And yet, there's all this stuff we need to do. We need your help. We need help from the developers. We need to be modest and humble about that. And we also need to stop working so much damn overtime in an attempt to hide the fact that what we thought we could do is not what we're actually able to do in the time made available. Because as soon as we start doing that, we help our product managers to remain infantile because they don't learn the fact that we don't understand what's coming. We don't know the future. We don't know about the problems in the product. We don't know about the configuration problems that we're going to face with the environments. We don't know about the unclarity of the requirements documents or the unavailability of some key person that we needed to talk to today. We need to help program managers understand we need a bit of slack. We need a budget, a kind of extra time in our back pocket that we can use, but we should declare when we are starting to use it so that we know when something that's a surprise starts to dominate our work and get us off track. If we don't do that, we will get off track and nobody will know about it. We'll just stay late trying to work around the obstacles that we face. And that's why we have to tell the third part, the third level testing story, a story about the quality of our testing. Why the testing we've been doing is the most fabulous testing that anybody could do. And if it isn't, why not? The help we need, the obstacles we're facing, the issues that we're encountering, the things that are making testing harder or slower, some of those things we can resolve on our own. Some of those things we need help for. And if we don't inform managers of the fact that we need help, we won't get that help. And they won't learn that testing software, developing software is a messy business. By defending them from that nasty surprise, we're setting ourselves up for worse surprises. Oh, we can get it done. Nah, let's be realistic. If we're finding out that we're not going to be able to get it done on time, let's report that the moment that we encounter it. Why is part 3 so important? Bugs threaten the value of the product, and we need to be able to find bugs quickly. But issues, as I said, give bugs more time and opportunity to hide. And if we're encountering issues, basically we have two choices. We can suck them up and then have management come to us 6 months later and say, why didn't you find that bug? Or we can tell management about the issues and remind them that 6 months from now, when they come to us and ask, why didn't you find that bug? We gave them the answer today. We didn't find the bug because it was hidden. And it was hidden so well that the people who actually hid it, they couldn't find it themselves. We didn't hide it. And therefore, let's make a more testable product. Let's straighten out things on the project that will help us to get information back to you, dear product manager, more quickly and more thoroughly. Let's put testability interfaces into the product. You know what? It takes a lot of extra work, a lot of extra time for us to walk up and down the hall. Let's put the developers and the testers together in the same place. So that when I have a problem, instead of having to get on instant messaging or walk down the hall or go to another continent, I can instead say, Phil, over here. I want to show you this. Let me give you two more things. First of all, a couple of global substitutions. Macros. To improve the quality of your testing, and if you're managing testers or if you're a customer of testers, you can use these same things and the quality of the testing will go like that. Pretty much guaranteed. Number one, when you see in an instruction or advice or a suggestion to a tester the word verify. Change that to challenge the idea that. Okay? Verify that X, challenge the idea that X. Verify that the program does this, challenge the idea that the program does this. That's what we mean by testing the program. When you're tempted to say investigate, or when you see it, reading it, validate, change that to investigate. Validate, investigate. When you see confirm, change that to falsify, right? Try to make sure that this is not true. And of course, if it is true, and you try to make sure that it's not true, well, you get it is true for free. But if you confirm that it works, that's what you'll focus the tester on. And the tester won't be testing at all. The tester will be demonstrating. Not experimenting, just following a procedure. And remember, demonstration is not an experiment. That's the difference between a marketer or a salesman or a stage magician and a scientist who's trying to discover some truth about the world. Truths about the world. Whenever you see we have to, whenever you're thinking we have to do this, we have to run a full regression test on every build, think we choose to. Because what that does is it opens the door to the possibility that there are other choices available. Slavery was outlawed in New Zealand generations ago. We don't have to do anything. We choose to do things, and those might be good choices, and there might be alternatives available that are wiser choices. Because the whole business of regression testing that we got right now is this fantastical thing where we have a bunch of automated checks and we run them again to make sure that everything works. No, we run them again to make sure they produce the same result they produced last time. The product can still have lots of problems that are evading our checks, and we need to investigate the possibility that those problems are there. Go ahead, run the checks, that's fine. But don't become fixated on them, because fixation is really bad for testing. Fixation will help you miss lots of bugs. So, questions. Not very good questions for testers, I would say. Is the product done? Testers are not in a position to make that declaration. Any testers who are being told to sign off on the product, just ask, why, thank you very much, I'll sign off on this. Could you help me understand, though, when did I become the product owner? When did I become responsible for business decisions? Could I have the product owner's salary, please? A business card and a plaque on the door that said product owner, that'd be very nice. That's the product owner's job. I'm using product owner as in a sort of non-agile way. I'm using it in a small a agile way, I guess. Project manager, product manager, business manager, whoever has responsibility for the shipping decision, that is the owner of the product in the way we think about it. And if you're the tester, that's weird. That's weird. Because testers are involved in technical investigations. They're not involved in shipping decisions. They inform those shipping decisions. So, are we ready to ship? As a tester, I don't answer that question with a yes or no. No way. What I do is I'll say, here are, based on our collaboration, you and I, dear product owner, we've been working on this all the way through. Here are the 10 most important problems that I still see in the product. And here are the areas of the product that I think you would probably want to cover before we ship. Maybe. It's up to you. And if they say, no, it's okay, we don't care about that, don't care about that, don't care about that, don't care about that, and we're prepared to accept the risk of not covering this. And I'll say, well, here's another 5, just in case. Here's 5 that you might not be. I'll give them a list of things that I see as issues in the product, and they make the shipping decision. That's what it means to be a product owner. How much time do you need to test? We want to ship on June 30th. How about August 22nd? Unacceptable. How about May 6th? 7 weeks of you sitting in your hands doing nothing between you finishing your testing and us shipping on June 30th? Unacceptable. Well, how about we just test until June 30th? I'll start testing right now. I'll produce information for you every day. I'll check in with you every day, all the time. I'll tell you what I've done, what's still left, what's still interesting, questions I've got about the product. I'll report on that every day. And if we get to June 29th and you say we have to slip a week, that's fine. I'll keep testing. And if we get to June 15th and you say, hey, it looks good to go, I'm cool with that too. How about you make the shipping decision and I will be your faithful observer of the product all the way along. From the moment you decide you want to develop the product to the moment you decide to ship, I'll be with you. How many test cases are passing and failing? 1,000 are passing and 50 are failing. Unacceptable. We need a better pass rate. Okay, I'll just run 25 of the 50 failing ones, and that's it. That's much better. My answer to that is, I'm sorry, misleading you is not a service that I offer. Let's talk about problems in the product, not how many. It's like asking Woody Allen, how many worries did you have this morning, right? As a neurotic, the number of worries that he had is not important. We could talk about whether his worries are relevant or significant or not. How many test cases have you run? Same deal. How many ideas did you have in the shower this morning? I had 2. One was, a lot of the problems that we're having in the Middle East could be solved if only we could get the Israelis and the Palestinians settled in terms of their relationships with each other in a way that it was mutually equitable and that satisfied all of their needs and aspirations. That was one idea I had. The other idea was, where did that black fluff between my toes come from? 2 ideas. Test cases are like that. They don't tell you anything about. How many doesn't tell you anything. How many bugs are in the product? Same deal. Much better question. What's the story of the product? Please, as a product owner, I wanted to ask you, what is the product story, dear tester? Can you tell me about things I need to know? What risks should I have in my mind? If you think there's important testing that still needs to be done, I want to know about it. I want to know about what you've covered and what you haven't covered. Could you tell me about that, please? I want to get you your help. What problems are slowing testing down? What specific problems are making testing harder? And as a tester, if I'm not being asked that question, I'm going to ask the product owner to ask those questions. I'm going to help the product owner manage me. Really, what product owners want to know is this. I can tell you exactly what they want to know. My experience is. What product owners want to know is what problems might be threatening the on-time successful completion of the project. If they're not asking that question, let's help them learn to ask it, and let's provide them with expert, reasoned, well-modeled, well-studied, experimented, explored answers. And then we'll be providing service to our clients, to our customers, and I think to society at large. Thanks very much. How is it that the testing business became fixated on test cases as a model for testing? I think it comes from there are 2 sort of big strands that flowed into it. One was in 1972, there was a conference called the Conference on Program Test Methods, University of Chapel Hill, North Carolina, in which Bill Hetzel, still an influential figure in the testing community to some degree, convened a bunch of people, mostly formal methods fans, methodologists, process model enthusiasts, right? And he gathered them together and they said, well, what are the ways of testing software? Well, what happened, I think, is that they saw 2 problems. One, how to make provably correct programs, and the other, how to deal with this messy, complex, political, psychological, emotional, human, squishy stuff. And like good formal methods people, they ignored that, just pushed it all aside. And that's one fork. The other fork is, I think, that in an effort to oversimplify testing, to make testing tractable and legible, a bunch of consultants created, and a lot of them not actually knowing what testing was all about, really, so far as I'm concerned, not thinking in terms of the historical meaning of testing, said, we don't know how to tell our story. Well, what can we do? And managers who didn't know anything about it either said, well, give me a list of things you want to check in the program. And they gave them a list, and they said, oh, wow, there's 30 things on this list. That sounds expensive. Can you get it down to 25? And I mean, this whole sort of over-abstraction of things started to evolve. We lost the thread, I think, of the notion of testing as investigation. The second fork, the second big stream in this river, was that through the educational system, people came to believe that the most important thing about a scientific experiment was repeatability. And that got mistaken actually for repetition because of the same experimenter's regress problem. You're in school. This happened to me one time, and I was really lucky to get a teacher who corrected it. Most teachers, I don't think, would do this. I was in school, and we made a simple calorimeter out of a styrofoam cup. Okay, and what we did was something like we poured boiling water in the styrofoam cup and then charted our observations over a series of several minutes. And I think my issue was the water when it went in was only like 75 degrees Celsius, and it was supposed to be boiling. So I took everybody else's results. I was quite young. I took everybody else's results and said, oh, well, my curve doesn't look like their curve. I'm going to make my stuff fit their curve, right? So I forged the results, basically. And the teacher said, no. Is this what you observed? And I said, well, yeah, this bad result? Yes. And he said, no, it's not a bad result. That if you're going to do science, it's important for you to account for what you did. And if we can't explain it, then we'll do another experiment, we'll study it, and we'll try to figure out why you got this aberrant result. What kids learn from the opposite thing, which is just no, that's wrong, go back and do it again until you get the right result. What kids learn from that is demonstration. They learn that science is all about procedure and not about experiment. Now, of course, there's procedure in experiment if we want to reproduce the experiment. But we're not talking about the replication part here. What we're talking about is the discovery part. Then that got perverted into something, well, let's do the same experiment over and over again and see if we get the same result. Well, that simplifies testing enormously, right? You gotta be compassionate to these people. They have a complicated problem, and they want to address it in whatever way they can. They're desperate. And so, well, this would be, let's just run the same test again and see if we get the same result. But that's not about exploration, and it's not even about experimentation. It's demonstration. And there's one more pathology associated with that, and that is, somewhere along the line, early 2000s, we started to call them acceptance tests in Agile world anyway. They're probably called acceptance tests before that. But they're checks. They're not tests. They're programmed, right? They're encoded to be performed by a machine, in that sense of acceptance test. So they're checks. Plus, an acceptance test that passes, a whole slew of them even, doesn't tell us that the product is acceptable. It does suggest, if they fail, it suggests that there's a problem with the product that we want to examine, and we don't want the product to go until we've examined it. Therefore, they're actually rejection checks. If I had been around in 2000 or whenever it was that somebody declared that what we're going to call these things is tests, test-driven development, it's not test-driven development, it's output check-driven development at the checking part. You could say it's test-driven development when you think of development itself as a set of experiments. Can we learn about this product through experimentation? Can we develop it through experimentation? In that sense, test-driven development is an okay moniker for it. But people became fascinated by the checks. So I would like to see it as test-driven development rather than check-driven development, which in reality is what it is for a lot of people these days. So those are the two strands. Science is repetition instead of repeatability, different, and this sort of a dismissal of human aspects of testing software on the part of these methodologists. You asked, what about this notion of test cases that don't provide a clear, specific result in advance? Isn't it the case that test cases don't really support circumstances in which we don't have a deterministic answer? That has been something that people have been aware of at least since 1980. Elaine Wyuker wrote a paper for New York University or something like that. I forget I could give you the citation if you let me look it up later. She wrote a paper in which she is a very clever paper on testing of untestable programs. And she points out there are dozens of ways in which we don't have an expected predicted result. Yeah. One of them was, for example, supposing we're writing a program that does climate modeling. Well, we can't have an expected predicted result. Nobody's ever written a program like that, or at least that was the case when we're doing it. Or we've got a new model that we want to test out. We're using a computer as a tool. Well, it's hard to say what the right answer is going to be. And that requires an analysis and evaluation and a study and modeling and so on. So she called that, I think she was smart enough herself to recognize that this program is not at all untestable. It's just our definition of testing is wrong. She didn't quite say that. James and I would sort of loudly say that these days. What she means is uncheckable programs. And part of this comes down to the problem set up by a guy named W.E. Howden, who introduced the word oracle into the craft. And his heart was in his right place. We get it. We didn't know then what we've learned since then, which was he focused on the oracle as a source of correctness. Right? The idea that an oracle tells us what's correct, which is sort of ironic because the Oracle of Delphi never told you anything that specific, right? It was always vague and subject to interpretation and elusive and elusive, right? If you wanted the truth from the Oracle, you weren't going to get that. You would get a poem. You'd get an allegory. You'd get a metaphor, which you, of course, were free to interpret whatever way you liked. And okay, then I will invade Persia, right? I do have to worry about this grandson of mine who is actually going to rise and steal my throne from me. But the oracle never said, oh, by the way, your grandson is going to rise and steal your throne. It said something confusing that you had to interpret. And if we thought of oracles in that way from the get-go, we would have been in a lot less trouble, I think. We're not testing to show that an algorithm produces a correct output. We're testing to identify whether the product produces value for people and to identify anything about the product that would threaten that value. So I love the question. It's a nice way of shining light on what the issue is here, I think. An issue.